In this problem, we want to graph y equals -1/2 cosine of 2x. So we're going to start with the graph of y equals cosine of x as the basic function that we're graphing. Notice also that we have some key points labeled on that graph. Now, what we do is notice that two things are going on. One, the 2 inside the parentheses, or as part of the argument, is going to cause a horizontal compression by a factor of 2. In other words, to obtain the graph of y equals cosine of 2x, we would multiply each x coordinate on the graph of y equals cosine of x by 1/2, 1/2. Then the -1/2 out in front of the cosine function is going to cause two things to happen. The negative causes a reflection about the x-axis, and the 1/2 causes a vertical compression by a factor of 1/2. Meaning, we can obtain this graph by multiplying each y coordinate on the graph of y equals cosine of 2x by -1/2. So we're going to deal with the horizontal issue first, the vertical issue second. So to graph y equals cosine of 2x from the graph of y equals cosine of x, take each x coordinate on the graph of y equals cosine of x and multiply by 1/2. So instead of -pi comma -1 being on the graph, it's now going to be -pi/2 comma -1. Instead of -pi/2 comma 0, it's going to be -pi/4 comma 0, etc. Doing this, we obtain the following graph. Now what we're going to do is obtain the graph of y equals -1/2 cosine of 2x. Well, we have the graph of y equals cosine of 2x. To obtain the graph of this function, we're going to take each y coordinate on the graph of y equals cosine of 2x and multiply by -1/2. So no longer is -pi/2 comma -1 going to be on the graph. It's now going to be -pi/2 comma 1/2. This point will remain unchanged because 0 times -1/2 is 0. No longer is 0 comma 1 on the graph. It's now going to be 0 comma -1/2. So we have a reflection and a vertical compression going on to obtain this graph. And here's the ultimate graph that we ended up with. Notice that the key points that we talked about are in fact on this graph.